Good afternoon, everyone here. We are the Bee Bioenergetic team, and we will talk to you about the topic biodiesel from renewable oil as a fuel source for Stirling type steam engines.
Now we have the table of contents. First, we're going to have a little bit of an introduction. Then we're going to see the process that we had. That's divided in stage 1, stage 2, and stage 3. Then we're going to see results from this process. Then we're going to be having the discussion, our current situation in Mexico, and the conclusions.
In the introduction, we have that the Stirling engine is an external combustion engine that works with a great variety of energy sources such as biomass. This type of engine operates volumetrically through a thermodynamic cycle in which air, helium, or hydrogen are normally used as the working fluid. The engine has the economic and technical conditions to become one of the most prominent technologies to be used in the supply of electrical energy in regions where biomass can be used due to its characteristics of being external combustion. It can work with almost any heat source, including direct burning of biomass. The general objective of work is to carry out a bibliographical research on obtaining biodiesel from used edible oils as an alternative to fossil fuels for use in a Stirling type steam engine. Likewise, there will be disseminations among the student community of the engineering divisions, University of Guanajuato.
Stage 1. Number 1.
The materials that we select based of the bibliographical reference are described below. The used oil comes from different places. Sodium hydroxide, methanol, and phosphoric acid were used. The reactor is cylindrical in shape with a conical bottom of 300 liters of capacity, a 4-level agitator at 400 revolutions per minute. An auxiliary tank was used to dissolve the sodium hydroxide in the methanol at 400 revolutions per minute. This scheme explains the phases of the procedure in detail, which consists of a pre-treatment for the oil by means of filtration with a fine mesh. The second one is the transesterification with sodium hydroxide, which is divided into two stages, followed by aqueous washing in triplicate to different conditions of temperature and time. And the last one is the drying. Its function is to eliminate a residual moisture.
Stage 3. The Stirling engine was invented in 1816 by Robert Stirling. The Stirling engine is a type of heat engine. Its operation is based on the expansion and contraction of a gas. The ideal Stirling cycle consists in process 1 to 2, isothermal expansion of the working fluid with the supply of the heat from the heater. 2 to 3, removal of isocharacteric heat from the working fluid to the regenerator. 3 to 4, isothermal compression of the working fluid with heat removal to the refrigerator. 4 to 1, isocharacteric heating of the working fluid with the heat supply from the regenerator. Stirling motors have multiple applications in different fields such as mechanical output and propulsion, electricity generation, and heat pump.
As a result of stage one, we had this table that we made where we organized the information that we obtained from our research. This was mainly taken out of all the articles that we researched. First, we divided by the title of the article, then the methodology they used on the article and the results they obtained, and finally the reference from where was took this article and by who was made this article. So this helped us to have our information organized and summarized.
Result. Result. Stage 2. Here is a map made in the BossBeWare software with the help of the reference investigate in EndNote software. The map shows a list of the terms that are most frequently repeated in the articles investigate for the relation of our final project. The reference investigate with the help of the software were approximately 500 bibliography references, which were integrated with the help of both viewers for the subsequent relation of the map shown here.
The results that we obtained from stage three was this table where from all the research that we did, we compared the different articles and we saw which ones had the more like suitable parameters for obtaining the best biodiesel that we could have.
The parameters with the greatest impact on the efficiency of the motors are the interception factor and the convective losses in the cavity, as well as the heat flux supplied. In this analysis, a comparison was made between the literature and a simulator used by the authors of the article. When the solar irradiance increases, the system increases the capacity and the efficiency. However, the absorber's surface temperature rises considerably. Here we have a compilation of all the parameters for an optimal engine operation, like the specifications for the motor, like pressure, like speed, or like a camera. We have another parameters like is the absorbance, like is a compression, how how long has to be the, the columns, and also the material that we're gonna use.
In the discussions, we obtained that the factor that almost influences the yield of obtaining biodiesel with the convection heat methodology is a type of catalyst. A higher yield is obtained by applying metallic sodium in the process. Subsequent studies of the equipment used reveal the presence of residual sodium hydroxide the tank used to make the methanol NOH mixture. This finding is thought to have negatively affect biodiesel production. Biodiesel production from used cooking oils is technically feasible. Special attention should be paid when dissolving the NOH since it has been seen to significantly affect the acidity and viscosity variables of the product and could, as in this case, produce non-conformity with quality specifications.
Now, talking about the current situation in Mexico, we have that more than 40% of homes in Mexico have a lack of energy, so they can fulfill their basic needs. And this problem has only been growing since the current federal government has supports fossil fuels. And we know that fossil fuels have a lot of disadvantages, such as that they really are nocive for our environment and also that they depend or rely on international treaties and international market, so we can have crises such as the one that we have on COVID-19 pandemic. And so our proposal is that these percentages percentage of people that cannot be supplied with enough energy so they can fulfill their needs can be supplied with some other energy alternatives, such as the one that we're presenting in this project.
Conclusions. The recycling of edible soils used to obtain biodiesel is a viable alternative from a technical, ecological, and social point of view. The use of biodiesel in this type of prototype shows us that the environment can be improved through the use of alternative energy sources, making use of engines that work from clean energy, as is the case of the modern Stirling type. From the point of view of environmental engineering, all this shows us the importance of implementing and innovating in this type of technology, and that they are not only seen as economic option to satisfy a need, they should also be considered as an option that contributes to an improved environment, because this is what an environmental engineer looks for.